All right, boys and girls, welcome to day 12 of SAT Countdown series. And today we have ratios, rates, and proportions. Now, my goal is with today's lesson, by the end of this video, hopefully, you'll have a good idea of how to simplify and compare ratios, calculate unit rates, and apply them to real-world word problems, mostly because that's stuff that we see in SAT a lot. And also solve proportion questions, which is SAT's way of scaling things up or down. Now, I'm sure these are the skills that you already are familiar with, but now that we're getting closer to the exam, it's important to brush up on those and do as much practice as we can. So we're going to spare a lot of time today doing a lot of problem solving, but I will briefly talk about each of ratio, rate, and proportion individually. We're talking about the ratios first. Now, a ratio is just, in essence, is just a comparison of two quantities, right? A ratio could be written as, for example, 3 to 5, right? Or sometimes you might see it written as a fraction. But doesn't matter. The idea is basically comparing two quantities. So, for example, you could say some hydration liquid has 1 to 4 of salt and water ratio. Just saying, right? It's just a comparison. Now, the key SAT trick here is understanding and knowing whether the test is asking for part to part. So part to part ratio, or part to whole ratio. Part to whole ratio. Once you understand that, these problems are becoming pretty easy to solve, right? Now, what do I mean by part to part? For example, imagine you have 20 students in the class. So if you're talking about the ratio of boys to girls, that would be a good example of part to part, because they're both part of the whole, right? But when you're looking at part to whole, this is one side needs to be the whole. If you have done statistics, when we have samples and population, this is similar to that. So part to part is sample to sample, but part to whole is sample to population. So if I have 20 people in the class, boys and girls mixed, so if I'm talking about boys to the class, that's part to whole. Again, also girls to class, right? It's important to identify them because you can make little mistakes with numbers. Another important skill for ratios is scaling, right? For example, we're going to do some examples, but if you're given, for example, internal angles of triangle, and then the question says the angles are, I don't know, 3, 5, 7 ratio, right? That ratio, we usually write that whenever we try to solve that equation, we multiply them by something. We say 3x plus 5x plus 7x, and if you're familiar with the internal angles of triangle, you know that they add up to 180. So we say, 3x, 5x, 7x should be equal to 180, and then we find what x is, and then we multiply them by all of them. So always remember that ratios are very flexible. They're very flexible in a sense that you can multiply and divide them. As long as you do it to all the things that are involved in ratio, you can scale them up and down. Okay? So with that being said, let's solve some problems. The ratio of 1/3/4 to 2/1/2 is equal to the ratio of 14 to what number? Right, so what number is basically what we are looking for, right? So we can call that one x. Now, we're dealing with four values here, right? So this is first one, this is second one, this is third one, and x is going to be our last one. So all we have to do is just write the actual ratio. So 1, I just closed, I can't see what this is. Delete that. So 1/3/4 1/3 over 4 ratio to 1 over 2 equals to 14x. Now, we can treat them as fractions. So what I'll do here, I will write them as fractions, but I also want to write them in an improper fraction form. So this will be 4 over 7 divided by, or it's a ratio, it's not really a division, but we can treat it as 1, and 5 over 2, and that's going to be equal to 14 over x. Now I can cross multiply. It's going to become 7 over 4x and 14 times 5 over 2. Now I can simplify it a bit further. So if I divide both sides by 7, these will go away. There will be 2 left, and this 2 can also be cancelled with this one. So 7, 2 at the bottom, 14, they will all cancel each other out. I will left with x divided by 4 equals to 5. So x is going to be 5 times 4, which is 20. So the answer is going to be. And the last one on this topic, this is a good question. Let's try to solve this one. Feel free to pause the video so you can try it out for yourself. The ratio of the length to width, the ratio of length to width, I like to highlight things as I read through them. So length to width, if you can take further notes, that even better, of a rectangular garden is 6, 7. So 6, 7. I can also write it at L divided by W equal to 6 divided by 7. If the perimeter of the rectangle is 78, if the perimeter is 78, P is 78, what is the area of the garden? Okay, we're given perimeter, we're asked for garden. Now, if I need to find the area of something, I need to know the sides. So I have a rectangle. This is L, this is W. I know it's 6 to 7. Length to width of the rectangle is 67. Well, that seems a bit strange because length to width, it says it's 6 to 7, but length should be longer than the width, no? So, but I don't think it will matter anyways, but there is some issue there. If the perimeter of rectangle is 78, so what is a perimeter of rectangle? It's equal to 2 times length times width. Okay, and it says it's equal to 78. Now remember at the beginning of the ratio conversation I said we can call them, usually do like 6x and 7x, so we can actually assign a variable to them and find out what they are. So I'm going to do that. 7x plus 6x is equal to 78. Divide both sides by 2. 13x is going to be, I want to say 39. Yes. And divide everything by 13. X is going to be 3. So, but what is x though? X is just 1 unit. So length is going to be 7x and width is going to be 6x, which makes this one 7 times 3, 21. And width is going to be 6 times 3, which is 18. So, now what is the area of the rectangle? It's going to be 21 times 18. Why? Because the area of the rectangle is length times width. 21 times 18. I'm not sure what that is. 21 times 18. 20 times 18 is 360. Plus 18, it's going to be 378. Just did a bit of a mental math there. Okay? For people who are interested. So I can write 21 as 20 plus 1 times 18, and then etc., etc. Anyways, but you don't need that because you have a calculator. Good? So that is ratios. When it comes to rates are basically ratios, right? They're just basically ratios but with different units. The most familiar examples you've probably seen and heard and worked with is speed and distance, or speed and time relationship. So we say miles per hour, or depending on the region you're living, kilometers per hour. Now, another common one could be, for example, cost per item. Now, you'll see these questions in SATs a lot. So, rate, you can also be familiar with rate if you have done calculus and talked about the rate of change and etc. You could also be familiar with that, and it might get a bit confusing if you're trying to compare this wording to that. But rate is much simpler in SAT. Now, SAT usually tests rates in two main ways. First one is unit rates, like the one I mentioned, miles per hour, or how much gallon of diesel you burned per mile, etc., something like that. We'll see some questions about that. And the second one is applying rates in word problems. Now, we're going to have some questions about that as well. Okay. Now, the big strategy in rate questions is always think per one. Okay. So, by per one I mean like per 1 mile, per 1 hour, per 1 unit, right? Because if you treat these questions with that mindset, the SAT questions are quite easily solvable. Okay, so let's see some questions. Question 1 says, if 20 machines produce 1,240 printers in a day, how many more machines are needed to produce 1,984 printers a day? So, now, to approach this question, again, we said rates are basically ratios, right? So what's the ratio? 20 machines produce 1,240, so 1,240. If this is the case, how many more machines are needed to produce 1,984? Now, because this is the ratio, or the rate, how we're doing it. If we have 20 machines, we're going to print this many. So if we are increasing 25, well, eventually we're going to find what the ratio is. But if we increase the machines, that will increase accordingly, right? It's not going to be like an exponential relationship or something like that. So if we have 10 machines, we're going to do half of that. If we have 40 machines, we're going to do double of that. Okay, so that's why we can write it as if 20 machines gives us 1240, how many machines will give us 1984? Okay, so 20 over 1240 equals to x 1984. Then you just have to cross multiply this, and if you do that, you're going to get x 20 times 984 divided by 1240, and I believe that's going to come to 32. Yes? Now, what is 32? 32 is how many machines we need to print 1984, but that's not really our answer though, or that's not really the question. The question says, how many more? And the sneaky thing is 32 is actually in the answer. So as soon as although I prepared these questions beforehand, I was tempted to just circle the 32 because I just found it. There's that feeling that you finish the question, you see answer, and you feel like that's the you circle that one immediately. But you always have to read the question carefully, always. And if you can, you should highlight the specific thing that you're looking for when you're reading the question. Okay, so we need how many more machines are needed. We already have 20 and they're printing 1240. We need 32 in total, so that means we need 32 minus 20, which is 12 more machines. 12 more machines to print the amount that we needed. Okay, very simple question, but could easily be wrong because of that 32 thing. Okay, I'm looking at the second question now. If 3 over 4 quart of lemonade concentrate is mixed with 6 2/3 quarts of water to make a lemonade for 40 people. So this much concentrate, this much water gives 40 people lemonade. How many quarts of lemonade concentrate are needed to make the lemonade for 24 people? Interesting, yes? How much lemonade concentrate we need? So 3/4 for this much water gives us 40, but we need 24 people, not 40 people. So probably our answer is going to be less than 3/4, right? But how less? Let's see. Let's see what type of a relationship we can build here. Okay, so 3/4 is, now this one is a bit strange because there's a bit more numbers than we would like. So that water might throw us off a little bit, because usually with ratios, even in the previous question, you have 3 numbers, you're looking for the 4th one. But here we have 4 numbers actually with 24. So it seems a bit strange. But since we're looking for the concentrate, we can avoid the water conversation now because we don't need the water thing. So 3/4 concentrate gives us 40 people. How much concentrate is going to give us 24? That's all we need. Cross multiply that. X is going to be what? 3/4 times 24. And a little bit more algebra. 4 cancel 6. 6 and 40 can cancel by 2. This is going to be 3 times 3 divided by 20. And that's going to be 9/20. So let's read the question carefully one more time to see if we're looking for the right thing. How many quarts of lemonade concentrate are needed to make the lemonade for 24 people? Yes, so because we said X is the amount of lemonade we're looking for, we should be all right. So the answer is going to be 9/20. All right, last piece we're going to look at is going to be proportions, and we're going to do some problems on that as well. Now, proportion is when 2 ratios are equal. What do I mean by that is, for example, 2/3. Actually, let me take 4/6 is also equal to what? 12/18, right? It can also be equal to 2/3. Yes? Now, SAT loves proportion questions because they show up and they show up in scaling problems mostly, like when you have maps and recipes and mixtures and resizing shapes and whatnot. So what I mean by scaling problems is when you have to take one thing and apply it to a bigger scale. Like map would be a good example, right? So if you have like a general map you have around is a scaled down version of the actuality, right? So, and same could be for recipes. So if you're applying, I don't know, 1 teaspoon of salt to bake a bread, or bake 1 bread, and then you scale it up, use 3 tablespoons or 3 teaspoons for 3 breads, whatever the case is, right? Now, the key technique here is usually is cross multiplication. You know, usually 3 of them are given. You have to find the 4th one, as you have seen in the previous ones. But the real challenge here is not to do the cross multiplication, obviously. The real challenge is to setting up the proportion correctly. So you're reading the word problem, you know, you're trying to identify what values you're given, like we did actually in the earlier example, and trying to set up the correct proportion, because once you do that, then the rest is easy. Okay, so we're going to be very careful when we are actually building our equation. So let's do some problems. Jason and Donnie painted, let me grab my pen here. Jason and Donnie painted a house and received $1,200. Received $1,200 for completing. To complete the painting job, Jason painted 4. There's a lot of numbers here, so let's highlight them. Jason and Donnie painted a house and received $1,200. To complete the painting job, Jason painted 4 hours and 25 minutes, and Donnie spent 2 hours and 15 minutes. If they split the 1200 in proportion to amount of time which each spent painting, how much did Donnie receive? Okay, so now how can we approach this question? How can we approach this question? Feel free to pause the video so you can try it out for yourself. But you can probably tell that we need to come up with some sort of proportion, right? Now, the total time they've spent. Well, actually, we don't know total time we've spent, but we can probably find out. We know how much they got paid in total, right? We know how much they got paid in total, so potentially, if we can find how much per minute costs, we can then find what each of them should get, right? Because it's a proportion question, right? So, now, there is nowhere in this question it says one is better worker than the other, one should get paid or not. So we don't have that. We know we have total amount. Let me switch to my black pen here. We know the total amount is 1200. Okay. We know Jason spent 4 hours and 25 minutes. Now, usually I sometimes do that as well. 4 hours and 25 minutes is not 4.25, yes? If you're not sure why, think about it. And Donnie spent 2 hours and 15 minutes, 2 hours and 15 minutes. Because 1 hour is not 100 minutes. I know we all know that, but I've seen people write 2 hours and 15 minutes as 2.15. Anyhow, so together they spent total time is going to be, actually let me write it at the beginning because I might need some space. So total time is going to be 4 hours, actually let me just do J plus D, right? If we add them up, I think, so we have 4 and 2, 6 hours and 40 minutes. So total is 6 hours and 40 minutes, okay? This is how much they spent. Now, if I take my total amount, money-wise, so I call it total, so I'll use the total, and divided by T time, I should get, so 1200 divided by 640. 640, we can write 640 as 60/40, right? This is going to give me like a per minute rate. Okay, let's see if that's the case. Now I might need to do a bit of algebra here actually. 1200 divided by 6. I can simplify this as divide by 20, 3/2. So 3/2. In fact, I'm going to write it as improper fraction. Improper fraction. So 623 can be written as 320. And that's going to be 1200 times 3 divided by 20. I can now cancel out. This is going to give me 60. So 180. 180. That's definitely not for 1 minute, because then it would make sense. We only have total of what? $1,200. So it's a rate of something. Now, what is it the rate of? It is the rate of hourly rate, basically, because we have 6 hours, right? 6 times 120 is approximately, it's getting there, and it's a bit more than 6. So this is an hourly rate. Hourly rate. Now, what am I looking for? I'm looking for Donnie. How much Donnie should receive? Now, Donnie should receive how much she worked. So Donnie worked 2 hours and 15 minutes times her hourly rate, which is 180. Yes? Now be careful here, this is not multiplication. Here this is 2, this is a fraction. Proper fraction. So if I bring it into improper fraction, 2 times 60 is 120, 135 times 180. I can cancel these out. This is going to be 3. So 135 times 3, whatever that is. It seems like there's only one number that ends with 5. So 405 is probably going to be our answer. Okay, so what did we do? We found the hourly rate and we just multiplied it with Donnie. I know it took a bit longer than what I just said because I said in 5 seconds, but that's the way to do it. Okay, so let's continue. The tennis balls in the bag are either white or yellow. The ratio of white balls to yellow balls is 3/10. So white, yellow is equal to 3/10. Which of the following could not be the number of balls in the bag? So this is a good proportion question. So if I have 3 and 10, that means I can write it as 3x plus 10x. That will be my total amount of balls, right? So 13x is how I'm going to scale it up. Now, can I have, for example, x can be 1, x can be 2, x can be 3, doesn't matter. But the proportion should always stay, right? If x is 2, for example, this is going to be what? 6/20 divided by 20. If it's 3, it's going to be 9 divided by 30. Whatever, yes? So, which of the following could not be number of balls in the bag? Now, our value is 13x. This will not change. X will change, obviously. So, the total amount of bags should always be divisible by 13. How do I know that? Because it's 13x should be equal to one of these answers. Total balls. So, 26 is divisible by 13, so that's good. 36 is divisible by 13, that's also good. 42, I don't think it's divisible by. 52 is divisible by 13, it becomes 4. This is 3, this is 2. 42 is not divisible by this, so this is going to be C. Okay? Next one, that was a good question. In a certain room, the ratio of males to females is 4:5. After 8 males enter the room, 4:5. Let's write that down actually. So male to female, that was not a good F. Male to female is 4:5. Again, the key here is writing the equation correctly. After 8 males enter the room, the ratio of males to females is 6:5. So if 8 males enter the room, my total male became what? Male plus 8 divided by females didn't change, but the ratio did. It became 6/5. Yes? What is the total number of people in the room before the additional males entered the room? So we're looking for M and F. Okay? Now I have 2 questions and I have 2 variables. I can probably do what? Treat it as a system of equation. Yes, I can take one, substitute, or I can write it into decimals, whatever the case is. So let's try it out. Let's do cross multiplication so we know what we're dealing with here. 5m is equal to 4f, and 5m plus 40, I just cross multiplied, equals to 6f. Okay, I see that I've got 5m's here, so which means I can probably subtract, do like elimination method. So I'm going to take the second equation and subtract the first one from it. That's going to eliminate 5m's. I'm going to have 40 equals to 6f minus 4f, which is 2f. From here I can find what f is equal to, which is 20. Once I find f, I can also find from the first equation, doesn't matter actually, but I'm going to use this one. So 5 times m equals to 4 times 20, because f is 20, and m is going to be 80 divided by 5, which is 16. Okay, so 16 male, 20 female. Again, I'm reading the question to make sure I got the right thing. What is the total number of people in the room before the additional males? So 16 plus 20, 36. Now, what's the deal here with this total number of people before the room, before the additional male? Now, we wrote the additional male plus 8. So M and F are still representing, they're still representing what? They're still representing the initial amount of male and female in the room. Okay, so that's ratios, rates, and proportions for you. Hopefully you guys enjoyed this session. Make sure you check out the other videos that I have uploaded already, and I'll have 11 more of them to upload because we are on day 12. And make sure you do a lot of practice. The exams are very close. SAT is all about practice. There's nothing really complicated in terms of topics, so do tons of practice. Ask me questions, and I will see you guys in day 11.